Good morning, everyone. My name is Luis Tovar, and today I'm going to be talking about the paradigms when it comes to aircraft automation. But first, let's start with a less complex machine. The majority of people are aware of fully automated automobiles. However, there is a divide in whether they trust these vehicles or not for everyday use. When it comes to airplanes, most people believe we have the technology to create a fully automated airliner. Nevertheless, a large majority of people would not board an airplane without human pilots. This is mostly because there is a psychological barrier that has to be broken in order to create a fully automated commercial aircraft. Humans like assurances, in terms like mutually assured destruction or shared fate, come into play. There's a famous phrase that says, "A captain sinks with his ship." Thus, passengers are assured that the pilot will do everything to save their lives in an emergency, and if anything, his or her own life. This is a topic that has to be analyzed very profoundly in order to comprehend what the future may or may not look like. Aircraft automation is fully dependent on the perception the general public has towards a pilotless commercial aircraft. So today, I'm going to be talking about some of the biggest challenges and benefits when it comes to making automation of aircraft a commercially viable option. These are some of the topics we're going to be looking at today in regards to challenges and benefits in full automation. We're going to dive into Boeing MCAS system, politics, human perception, and more topics. And even if these look like separate topics, they are deeply intertwined in the challenges of full automation for commercial aircraft as well as the benefits. Since the beginning of aviation, humans have always wanted to create new and better machines. The first successful flight was conducted by the Wright brothers in 1903. Only 9 years later, in 1917, the first autopilot was invented. This autopilot was known as the gyroscopic automatic pilot, and it was created by Lawrence Sperry. This is only to say that we are in a constant state of innovation, therefore we apply this innovation to every single industry, including aviation. Humans are currently in the fourth industrial revolution, which consists of creations like the internet and artificial intelligence. The fourth industrial revolution is far from finished. It is in a constant state of growth. Aviation is one of the industries that is most affected by this new wave of creations. In the past few decades, there has been an increase in research and development of new aircraft that are capable of flying without human input. For example, Boeing has developed an artificial intelligence aircraft known as the Loyal Wingman, which is designed to fly alongside fighter pilots to provide support in combat missions. This type of innovation usually starts in the military. However, it usually finds a way into the commercial sector. Airlines and aircraft manufacturers have been looking at implementing completely autonomous commercial aircraft into the national airspace system. However, this implementation comes with many risks and opposition from pilots and the general public alike. There are many problems that have to be addressed before automation becomes something viable. As an example, Boeing's maneuvering characteristics augmentation system is one of them. One of the main arguments against aircraft automatization is the perception of the general public. Most people would rather have a human flying the airplane in case of an emergency. Recent accidents caused by Boeing's Maneuvering Characteristics Augmentation System, or MCAS, have further jeopardized the view of the public towards automatization. These accidents include Lion Air and Ethiopian Airlines aircraft that crashed. And before digging into the topic, let's learn how MCAS works. A very basic explanation of MCAS is what you see on the picture. The angle of attack is measured by the incoming airflow. If this angle of attack is too high, the sensor will alert the computer. In turn, MCAS activates and lowers the nose of the aircraft to prevent the stall. However, when this malfunctions, it can be fatal, as in the cases I mentioned before. The sensor sends erroneous data to the computer, and the computer detects a stall. But if the aircraft is flying straight and level, then this becomes a problem. Boeing's MAX 8 aircraft was equipped with this system, but there are many things that led to these accidents. Sensor failures were one of the results of many actions that occurred before the aircraft even started flying. This case starts with the competition from the biggest aircraft manufacturers in the world, Boeing and Airbus. Airbus had to come up with a new aircraft called the A320neo. This aircraft was launched in 2010 and promised 20% savings of fuel, lower operating costs, and a better range. The Airbus 320neo was being offered to many airlines around the world. It was in direct competition with the older model of the Boeing 737. This meant that Boeing had to either accept that they were going to lose customers or they had to come up with a better aircraft immediately. And this is where the race began to offer a better airplane to the biggest airlines. Boeing's main problem was that Airbus was about to complete a big sale. In this deal, Airbus would be selling a substantial amount of the A320neos, so Boeing had to come up with solutions to retain its market share and its sales. So the answer was the 737 MAX 8. It was born with Boeing. Boeing started offering the 737 MAX 8 to American Airlines even before the design was approved by the board of directors. The design was formally approved around a month later by the board actually. And the process of design and approval looked rushed, and it did indeed come with consequences. The 737 MAX 8 is a version of the old 737-800. The new MAX 8 used the same design for the body, but it had larger and more efficient engines located further aft of the plane. Boeing engineers have found that because of the positioning of the engine, the aircraft could pitch up too steeply and stall. This is evidence of how human error arises everywhere, including design and manufacturing of an aircraft. Boeing engineers decided that it would be easier to create a software than to change the physical aspect of the airplane. Changing the design would mean that the aircraft would have to get recertified. However, Boeing promised a new aircraft that did not require a lot of training for pilots to transition. And the solution they came up with was called the Maneuvering Characteristics Augmentation System. And this subsystem was created to compensate for the extra pitch up produced by its larger engines at an elevated angle of attack. However, the system was designed poorly and led to many casualties prior to putting money over safety. If this can happen in today's world with pilots that could try to troubleshoot a design flaw, what would happen in the future if a poorly designed autonomous aircraft is sent to fly with passengers and no one to help? According to Chief Commercial Officer of Airbus, Christian Scherer, this is not a matter of technology, it's a matter of interaction with the regulators, the perception, and the traveling public. Airbus says that they are ready to deploy fully autonomous aircraft today. However, they acknowledge this will happen many years in the future. The barriers towards full autonomy are human rather than technical. Regulators are well known for taking long periods of time to evaluate and create new regulations. In this case, there are many concerns to create new norms for the future of autonomous planes. The main concern being the general public and their reactions. Regulators serve the people, and the people are still not comfortable with automatization. The Airline Pilots Association is heavily expressing their discontent with fully autonomous aircraft. A letter from ALPA, President Joe, states that the most important part of safety in aircraft is having two trained and rested pilots in the flight deck. Joe notes that the concept of autonomous aircraft is premature and that it would divert valuable resources from issues that are more pressing. And as you can see from the graph, to ask people where the government should prioritize investment, most people chose things like improving screening processes, improving air traffic control, investing in fuel-efficient technologies, and innovating. In regards to faster aircraft, only 4% of people use their first choice to say that the government should prioritize spending on creating unmanned aircraft. It should not be something we need to work on, especially because we are not comfortable with it. The people are not comfortable with it. They like having pilots on the flight deck. Pilots flying, do they have earned their licenses and wisdom through countless hours of hard work and studying. And there is no machine that can mimic the learning experience of a human, and the safety would be compromised for the millions of passengers that fly every year. Another big factor to consider before being able to launch a fully autonomous aircraft is insurance. Something we never even consider when we fly with an airline is that all their fleet is insured. But if passengers and aviation experts are not comfortable with automation, how do you convince an insurance company to accept it? Insurance companies base their prices on the experience of pilots and record of an airline when it comes to safety. There are many factors to think about when insuring a new technology, and this is not an easy assessment. Insurance companies will have to find new ways to evaluate risk in the future. Insurance companies will have to collect aircraft data that shows the behavior of the autonomous systems in various real-life situations. This means that insurance companies will have to start becoming technology companies as well, and they will have to work closely with software engineers from aircraft manufacturers. And this is how insurance companies will be able to accurately price insurance for the future. However, how do you reach the point where insurance companies are ready to comfortably insure a fully automated aircraft? Right now, they're comfortable to insure our aircraft because they know how pilots are trained and how they operate. Airline pilots that are capable of safely flying today's aircraft to their destination must undergo extensive training. But if you take the pilots out of the equation, insurance companies must evolve and change, which is not an easy task, especially for these companies that are already established. Pilot training brings us to another issue of automation. All of the training is conducted by flight schools, which may be big companies or small flight schools serving smaller airports. If aircraft automation is used, many of these flight schools would completely disappear, leaving thousands of people without a job or an income. Furthermore, pilots that are already trained will be fired from their positions, and many families will struggle for survival. This reality is another factor that would lead regulators to think about allowing fully automated aircraft to enter the market. The human factor is something that must be considered before thinking only about economic benefits for corporations. Human perception is the most important aspect of introducing fully automated vehicles, since the public is the user of said vehicles. Today we already use many automated robots for manufacturing in factories. However, these robots are not transporting people anywhere. We have several automobile manufacturers such as Tesla developing automated vehicles. But an automobile is far less complex than a machine and far less complex than an aircraft that carries hundreds of people at once. Human perception has to change before any fully automated aircraft can be introduced into the commercial world. Today, we are fully capable of launching a fully automated commercial airliner, but even if there is an aircraft capable of flying itself, the general public would be reluctant to fly in it. According to a survey, 76% of people would not fly in an aircraft with no pilots. And according to the Airline Pilot Association, another survey reveals that 85% of people would not feel comfortable flying in an aircraft with no pilots. Furthermore, 66% of people would not fly in a pilotless aircraft even if the airfare was 30% cheaper. This result shows that even with adequate technology, automated aircraft will not be a reality until the general public feels confident about flying in pilotless aircraft. As technology advances, there is always a percentage of individuals that are going to accept it, as there is a percentage that will reject it. To analyze this, we can use the innovation adoption curve. And this is a bell curve model that explains how people adapt to new innovations. It is divided into 5 categories: innovators, early adopters, the early majority, late majority, and the laggards. These classifications and percentages refer to the number of people that will start using innovations as time passes. Innovators will use the technology first, while laggards will use it last or will never adapt. In aviation autonomy, we are in the stage of early innovators, as we can see very few people that are actually adopting the technology. As aviation is a very particular case, individuals are not usually persons, but rather organizations like the military. The next category is the early adopters, which in this particular case will be considered as private commercial aviation. Privately owned jet aircraft would be the next step of automation. The early adopters category are from a high social class, have more financial freedom, and advanced education. Once these individuals are convinced to fully fly an autonomous aircraft, then perhaps the general public will embrace the technology. However, there are many steps to be followed and challenges to overcome. The next categories of the adoption innovation curve will take place with the airlines. Once the airlines start acquiring autonomous commercial aircraft, the customers will follow the bell curve and slowly adapt to the technology. Nevertheless, how fast or if the general public adapts to autonomous aircraft depends on many factors. Understanding the innovation adoption curve gives us more information on how challenging it is to implement fully automated aircraft. There are many challenges, such as convincing the general public to fly in an automated aircraft. Many decisions must be taken in basis of economics and how it affects employees, such as pilots. It becomes very complicated to implement fully automated aircraft. Perhaps in the future, there will be less challenges and more reasons to move towards full automation. But until then, there is a long path to follow to reach that point. Now that we have analyzed in depth all the challenges of having a fully automated airliner, we can dig into the benefits of encouraging automation. The shortage of pilots has always been a lingering problem for the aviation industry, and the graph you see here further illustrates that. This graph was obtained from Boeing and Forbes. It shows the estimated new pilot demand by region from 2018 to 2037. In North America, we see a need for 206,000 pilots. In Latin America, the number is 57,000. And for Europe, we will need 146,000 pilots. The region that needs the most pilots is the Asia Pacific location, which will require 261,000 pilots. And you can see the numbers for the regions I didn't mention on the graph. However, the important number we're looking at here is 790,000 pilots. This is an enormous number of pilots that we can barely fulfill with today's training. That number represents the total amount of pilots we will be needing in the future. The pilot shortage is only heightened by the number of pilots that are retiring. Baby boomers, who are the majority of pilots, are in close proximity of retirement. These pilots represent about 50% of the airline workforce for now. Furthermore, the shortage of pilots is heightened by the 1,500-hour rule, which was established in 2013 in the United States. This rule requires first officers that wanted to have an airline transport pilot certificate and consequently fly for the airlines have that number of hours to qualify, 1,500. The previous number of hours required was only 250, which means that the requirements grew exponentially. And conclusively, pilots are in great demand and they will continue to be. COVID-19 has severely affected the airline industry and the recruitment of pilots has halted. Pilots are constantly being furloughed and airlines have aircraft sitting without any flights. However, this is only temporary and pilots will continue to be in high demand. According to Kit Darby, an aviation consultant, pilot hiring will recover to 70 to 80% of previous levels in 1 year or less. Furthermore, a full recovery can be expected in a 2 to 3 year level. Once the recovery reaches that point, the next step is to continue growing as the world relies on being connected. This means that pilot hiring will continue to rise exponentially and more pilots will be needed. Pilot recruiting will start eventually, and when we do not have enough pilots to fulfill that demand, what's going to happen? The technological solution to the problem is embracing fully automated airliners. Aircraft today are heavily automated, and according to Airbus, we have the technology to have fully automated airliners flying in our national airspace system. This would mean that there is no longer the necessity to hire new pilots. Airline pilots, as we mentioned before, go through extensive training and they have to take recurrent training at the expense of the airline. When embracing fully automated airliners, there is no need for recurrent training either. A lack of pilots and moving to automation would mean a decrease in overall costs and finally solving the pilot shortage problem forever. Now let's talk about how automation can actually improve safety on airliners. Today we see many new technologies that amaze us and also create a safer environment. These automation technologies, when used properly, can enhance safety incrementally. We already see some of them in use, like Garmin Autoland, which is the picture that you see here. Let's dive into how this technology works and what it actually does to improve safety. By the way things are structured today, the pilot is solely responsible for the operation of the aircraft. However, what happens if that pilot makes a fatal mistake or is simply unable to continue flying the aircraft? This is when Garmin Autoland comes in for general aviation aircraft. Garmin Autoland essentially becomes the pilot when the human pilot is unable to take control of the aircraft in an emergency. Garmin Autoland can engage automatically if it detects the pilot is not capable of flying, or it can be activated with a simple touch of a button. The system will run calculations and find the most suitable airport to land. These calculations include range, weather, available landing distance, and many more. The system is capable of avoiding hazards like weather, obstacles, and terrain and flies safely to its destination. Garmin Autoland will also communicate with air traffic control and declare an emergency. Once the aircraft reaches its destination, the computer will handle the landing and will bring the aircraft to a full stop and switch the engine off. Garmin Autoland is an example of what technology is capable of in the present. This technology is incorporated in small aircraft with limited capabilities. However, airliners have all the necessary computers and sensors to implement this into everyday use. Now, the diagram you see here is part of a NASA program known as the Emergency Landing Planner. The system is specifically designed for large aircraft used by the airlines. The purpose of the system is to help pilots land an aircraft during an emergency safely with precision. This program takes into account all of the factors presented by aircraft sensors. It takes external factors into account such as weather, obstacle, winds, nearest airports, traffic, terrain, and many more. The system also takes into account aircraft factors such as range, fuel remaining, damage system, if any damage systems are in the aircraft. And it will also take into account the configuration of the airplane and many more. Once it gathers all this data, which happens immediately, the system will give pilots options to land safely. During a simulation without this system, pilots took approximately 20 minutes to reach a concrete decision on what would the plan of action be to land the aircraft safely. However, once the software was implemented, decisions happened in roughly 4 to 5 minutes. So let's use the diagram as an example. In this case, the aircraft is suffering a failure that requires immediate landing. The computer calculates all the parameters and takes control. It sees that there is an airport nearby, but considering the altitude at which the aircraft is at, it would take longer to land at that airport, as it has to descend before. Therefore, the computer decides to land at the second nearest airport, avoiding en route weather and icing conditions. Once it decides on the airport, it takes into account the facilities, the landing distance, and many other factors that would affect the aircraft. This software was aimed at helping pilots. However, if the pilots are eliminated from the equation, one could argue that the decisions would happen almost immediately. To give a more concrete example of how this technology would increase safety, we can look at US Airways 1549. US Airways Flight 1549 was a flight scheduled from LaGuardia to North Carolina on January 15, 2009. The aircraft, shortly after takeoff, was unfortunately hit by a flock of geese. The Airbus A320 lost all engine power and it was unable to reach any airport for landing. Consequently, the captain did a water landing on the Hudson River, and according to NTSB hearings and simulator tests, the aircraft would have been capable to return to land at Teterboro Airport. Nevertheless, when you consider the time that the human captain took to process what just happened, the task of reaching Teterboro would have been impossible. Furthermore, if there was no human pilot and instead we would have used the emergency landing planner combined with extra technology like impact sensors around the aircraft, the problem could have been immediately detected. Therefore, the decision to return to the closest airport would have made immediately by the computer. Technology can increase safety exponentially. It reduces the delay that humans take to reach, and there are no emotions involved in the decision-making process. Technology and fully automated airliners can improve safety drastically if used correctly and programmed correctly. There are many advantages of having automated airliners, but the most important one is the safety of the millions of humans' lives that fly around the world every day. Now, let's discuss some of the current technology that can make automation possible today. Airbus has been working on a project called Up Next. This project has been testing autonomous taxi takeoff and landing, also known as ATTOL, and these features are being tested for the past 2 years. 500 test flights were conducted which gathered raw data. These flights included 5 takeoffs and landings each. This means that 2,500 fully autonomous takeoffs and landings have been accomplished. The ATOL project gathers its data from automatic vision flights, and the aircraft uses onboard image recognition technology. Essentially, the technology gathers all the information necessary from cameras and sensors in the aircraft and around the aircraft. Consequently, this information is analyzed and processed by computers, which use machine learning to perfect the technique. It is very innovative technology, but it already exists and it's ready to be put in use at any time. There are many more projects like this, and one that further expand automation possibilities in the world of aviation. As it was previously discussed, innovations usually go first to organizations such as the military. In the aspect of autonomous flights, the military have been taking advantage of this technology for some time now. As an example, we will use Boeing's MQ-25. This is an aerial refueler. The MQ-25 is designed for the US Navy to refuel fighters with no need of pilots on the flight deck. This aircraft is designed to extend the capabilities of current piloted fighter jets. It is an unmanned aircraft system, or UAS, but it is controlled from the ground. However, further adapting autonomous technology into drones cannot be harder than putting it in an airliner with people. This short example just shows how much technology is developing, and most people don't even realize it. Humans are constantly advancing, and that means that perhaps soon, we will see autonomous aircraft flying in our skies. Although one of the main arguments against automation of mostly anything is the loss of jobs, there are many counter-arguments to disprove that. Even though it is true that some jobs will be lost due to automation, many more opportunities are created. New technology doesn't only remove jobs from the market, but it creates new ones that require more specialization. In this case, it forces us to expand our knowledge and ultimately become more precise in what we do. Opportunities created by automation are many. A study launched by Deloitte in the UK found that automation eliminated 800,000 unskilled jobs. However, that same study found that 3.5 million jobs were created that on average paid 13,000 more per year. This continues to show how automation in the long run can be a good thing. As the population increases, we need to create more jobs, and ironically, the way to do it seems to be eliminating some jobs first. As it comes to pilots, automation of airliners will undoubtedly remove pilot jobs from the equation. Nevertheless, many jobs will have to be created to support a growing number of aircraft in the sky worldwide. Passengers will continue traveling and air travel constantly rises. Thus, for every pilot job that is eliminated, there are many support positions that will be needed. For example, a fully automated airliner may need a ground crew tracking and monitoring its systems while in flight. There will be a high demand for software engineers to design and constantly improve the software for aircraft. Furthermore, there will be many government jobs created to support the Federal Aviation Administration in implementing new software into the National Airspace System to support all the automation. Aircraft automation has been a very debated topic for the past few years as technology advances and more pilots are needed. A steady increase of passengers and a low supply of pilots has made fully automated aircraft very attractive for airlines. Automation has brought many challenges when thinking about implementing it. The Boeing MCAS system has changed the perspective of the general public towards automation. It has made people more cautious with innovations. Most importantly, statistics tells us that people are not willing to accept fully automated airliners quite yet, even if tickets are generally cheaper. Automation still has to change the perception of the general public to become acceptable and commercially available. On the other hand, automation brings many benefits to the table. The shortage of pilots crisis can be solved by implementing systems that allow aircraft to fly themselves. Safety could potentially be increased with the right software and going through the precise development of new aircraft, emphasis on precise. Furthermore, the technology is already available and it only has to be fully implemented into the National Airspace System. Automation has the potential to create many new jobs as it would generate specialized jobs that pay better. Inconclusively, automation has many advantages, and all of them are being analyzed constantly to have the possibility of implementing a fully automated future in aviation. There are many challenges and many benefits of creating a fully automated aircraft available for the public. Airlines and private companies are constantly investing in research towards eliminating pilots from the flight deck. Nevertheless, even if the technology is already developed and available, the final decision will remain with the perception of the general public. Statistics continue to tell us that the general public is not ready to embrace fully automated airliners, but perhaps in the future, it will be an idea to fathom. However, fully automated aircraft are not part of what the general public considers acceptable. The biggest challenge is to convince the consumer that these aircraft have the potential to be safe. As long as that perception is not changed, fully automated aircraft will have to wait for their turn in the future. Thank you very much. Please let me know if you have any questions.